Okay, so in this video, we're going to be talking about writing the solution set to typically an inequality, although we are going to touch on what happens if you have a single loose point out there. This is a skill that is useful for writing things like the domain and range of functions, and also just as solution sets to both equations and inequalities. Now, there are three main types of notation that we're going to be looking at. We're going to be looking at drawing our inequality solution sets on number lines, writing them in terms of interval notation, and also set builder notation. Now, when you have solutions to equations, typically you're going to be using set builder notation. In some special cases, when you're doing domain and range, you may have a combination of set notation and interval notation. But we'll look at those examples as we go. So let's start with the basics. So if we have the solution to an inequality, usually when you're done solving the problem, it's expressed in the form of x, an inequality, and then the number that represents the cutoff between where there is a solution to the inequality, where the inequality is true, and then on the other side, where the inequality is not true. So in this case, if we have x greater than 4, then this is our inequality. Now, if we want to draw this on a number line, then we're going to draw a one-dimensional number line. Sometimes after we get used to working with 2 dimensions, sometimes students will forget that there's a 1 variable case and a 2 variable case, but this is the 1 variable case. So we have only a one-dimensional number line, not a grid of x and y coordinates. So this is, don't think of this as a vertical line. This is just on a single dimensional number line. So if I draw my number line, I'm going to put the location of 4 on that number line someplace. It doesn't really matter where you center your number line. So you could put 4 over here thinking the center is 0. That's fine. But what we're interested in is where the cutoff happens. Now you could add additional information like 3, 2, 1, 0, ... But for our purposes, that doesn't really help us to determine what parts of the number line are included and what parts aren't included. The number line always goes from the smallest end to the largest end, and so we work with that. So 4 is the place where we have the cutoff. And then we want to indicate the inequality to indicate which side of the inequality is included. So do we want to be less than 4 or do we want to be greater than 4? In this case, x is greater than 4, so that would be this side. And we can draw the arrow. Our arrow. And then we want to mark the endpoint in a particular way to indicate whether 4 is included or 4 is not included. Now, there's 2 ways to do this that are considered standard. One of them meshes with the way that we draw piecewise functions, and one of them meshes with the way that we write intervals. So I'm going to do an example of both in all of these examples, but you really only have to do one of them. I would suggest looking at your textbook to determine what the textbook that you're using does. Now, the older way, the way that meshes with the way piecewise functions are graphed, is to draw an open circle at the end if the 4 is not included, if there's no equal sign on your inequality, and then to draw a closed circle filled in to indicate that it is included if there is an equal sign here. So we'll do an example of that in a second, but here it's not, there's no equal sign, so 4 is not included. So you can go as close as you want to 4, but not actually 4. So 4.0000000000001, yes. 4, no. So greater than, but not 4. Now, the other way to do this, again, according to a method that looks more like our interval notation, the first several steps would look the same. We draw our number line, we plot our 4 on the graph, we draw an arrow to indicate which side of the inequality we're on. And then when the 4 is not included, as in this case, we would draw an open parentheses, which is what we'll use when we do the interval notation. And if 4 is included because there's an equal sign, then we would draw a square bracket, which would again match what we're doing with the interval notation. So in both of these cases, the interval notation would look like 4, comma, infinity. Interval notation always requires 2 numbers, the starting point and the ending point. So they are also always written in the order that they appear on the number line. This is important because I often have students who will flip the order, who will write the leftmost value second, and then that doesn't make any sense in interval notation. So it always has to be in the order they appear on the number line. So infinity is to the right on the number line, and so that is to the right of the 4 in the interval notation. So again, notice this parentheses matches the parentheses we use in the interval notation to indicate that 4 is not included. And then as you go off to the right, there's no stopping point, so you go off to infinity. And infinity never gets a square bracket because infinity is not a number. It is not a place where you stop that you can include. It is an indication that you're going off forever. Now, for the set builder notation, in some ways, the set builder notation for an interval, for an inequality like this is actually simpler because all you have to do is stick the inequality in some extra notation. So you don't have to really evaluate it. So the way that set notation works is that everything is enclosed inside of a curly bracket. And the brackets that you're using for these notations, square, parentheses, and curly, they matter for math. So if you swap them out, it's not really true. It's not really correct. So we would put X inside our curly bracket to indicate which variable we're writing the set for. And then this either a vertical bar or a colon would follow it, which is read such that. And then what would follow would be a condition. So in this case, the condition is the inequality. Now you can be a little bit more elaborate than this. You can say X is real, and then also and X is greater than 4. But X is real is usually understood. And so if you don't necessarily include it, that's fine. Again, the general format is you would have X and then a condition or conditions. And typically, again, you can write these out in a statement or sometimes in words, or you can write them out in inequality form. If you have multiple inequalities you need to satisfy, you generally do want to simplify them, but then you can just list if you have separate inequalities. That's fine. That's the general idea. Now, set builder notation is where we also get into what happens if we're solving an equation and not an inequality. And in those cases, you can just list the values. So lists for solutions to equations. Because equations, to start with, when we do linear equations, they're only have one value, like a number. When we get more complicated equations, we could have multiple answers, and in which case we would just list them. So if we want to say X equals 3, then our set notation would just be this. If we wanted to say X equals -2 and 4, then we could list -2, 4, again, in curly brackets. So equations usually are a list of values because they're discrete values, not a whole bunch of values. So then you would just list the values in set notation with the curly brackets. But when you're dealing with an inequality, set builder notation takes on this form where you have X such that, and then you list the conditions that need to be satisfied for X. Again, typically just the inequality. We'll continue writing these examples as we go. More often when you have inequalities, you're going to be asked to write them in interval notation. All right, so now let's look at what happens if we're doing x less than or equal to 5. Now, again, we can draw these on a number line, and then we can write them in interval notation and set builder notation. So I'm going to draw the number line again. There's my number line. There's my 5. Now, which direction is this going? Well, this is x less than 5. So go this way. Again, there's my arrow. And then this is equal to, and so what I would fill in is a dot in the first set of notation. I would fill that in as a solid dot to indicate that it's included, or I can, here's my arrow, and then put in a square bracket. And again, the square bracket and the closed dot, these are things that are going to remind me I didn't put enough returns. They're going to remind me that the endpoint is included. X can be not only up to 5, 4.999999999, but also exactly 5. Unlike in our previous example where we could be as close to 4 as we wanted, but not actually 4. Now, in interval notation, again, we're going to use this same square bracket, but it goes on the 5. And the other thing to keep in mind is you don't read the number line to the left. You read the number line always from left to right. So what is the smallest value on our number line? It is negative infinity. And then we stop at 5 on the right. It is wrong. Again, let me stress this. It is wrong to write this as 5 comma negative infinity. That doesn't make any sense. That is telling me that negative infinity is bigger than 5. It always has to go left to right. So one of the reasons that the number line can be really useful, even as you get into more complicated math, even if they don't tell you to write it on the number line, is that it can be a reminder of when you're writing out your interval notation that you're putting things from left to right and not thinking 5 is the cutoff value. That's the most important. I list that first. And then whichever direction I go from there is fine. It's not fine. And then again, set builder notation would just be X. And again, alternatively, you can do a colon here. It depends on the book. X, but it's still read such that, and then X less than or equal to 5. Again, curly brackets on the set builder notation. Now, you have these single variable inequalities where you have only one endpoint, either on the left or on the right, and then infinity or negative infinity on the other end. You can't have double inequalities. Now, double inequalities have values on either end. And they can have different inequalities. Now, the thing to keep in mind about double inequalities is that the inequality symbols themselves always have to be pointing in the same direction. So again, and they're going to typically be listed in the order they appear on the number line. So you can have a number that is less than X or less than B, or a number that is less than or equal to X, but less than B, or less than or equal to X and less than or equal to B. And so you could have all 4 of these combinations. But again, the standard way to write these is always with the smallest value on the left, X in the middle, B on the right side, which is the larger value, and then always less than, because you're reading from left to right on the number line. Again, that is standard. So let's draw that number line example. And I'll just pick some numbers actually so that we have some specific values to look at. So -2 less than x less than or equal to 3. And if I draw my number line, I would place, again, the leftmost value on the left and the rightmost value somewhere on the right. And while I'm using the black, I'll draw my second example for the other endpoint notation. Now, when you're drawing the where does this inequality apply? Again, it's typically in the middle in both cases. And then you mark the ends with the type of inequality you have. So in this case, number 2 is connected to a less than with no equal sign. So the fact that it has no equal sign means that it gets an open circle or a round parentheses. And on the 3 side, this has a less than or equal to sign. So equals to is an closed circle, so you fill it in. And in the interval notation style, you would put a square bracket. Again, this thing means that -2 is not included in the solution, but 3 is included. And again, these other versions, you could have versions that have 2 closed circles or 2 square brackets. You could have them switched. They don't have to match on either end. You could have ones that have both open on either side. It just depends on the inequality that you're graphing. And then once you have your number lines drawn, you can write your interval notation, again, following the one on the bottom, -2 to 3. Again, the brackets don't have to match. They have to match the inequality that you have. They don't have to match each other. And then, of course, in set builder notation, x such that, and then you just write your inequality, -2 less than x less than or equal to 3. Now, one thing that to keep in mind is that it is possible to have an inequality where the inequalities are pointing the other direction, but that's not standard form. And if they're pointing in the other direction, that's indicating that A is bigger than B. So if you have A greater than X greater than B, this suggests that A is bigger than B. And again, this would be the reverse of what they would appear on as the number line. So standard form, you would want to switch these to be consistent with this. And then again, it's easier to plot on the number line because they're on the number line. The inequalities cannot go in opposite directions. So if you have something like 2 less than x greater than 5, this makes absolutely no sense. Okay. Because what this is saying is that x is less than 2 and x is less than 5. So when a double inequality is an and form, and both must be true. So it is possible to be bigger than -2 and also less than 3. You can be in between those two values, and then you will satisfy both ends of the inequality. But if x is greater than 2, but also greater than 5, that doesn't make any sense. You can't be greater than 2 and also still be greater than 5 at the same time. If this statement was true, the only thing that you could do is to be greater than 5. So you can't do this. This is bad, bad, bad form. So I'm actually going to put a strike through this just to remind us, this is terrible. Don't do this. Occasionally, and we'll see this in another video, You can have and or conditions, but you can't write or conditions where two parts of the number line are being satisfied. You can't have or conditions written as a double inequality. They have to be written as two separate inequalities. And then you would use the union symbol to indicate that the intervals are, again, the union symbol indicates or, not and. When we're writing inequalities, we never use the intersection symbol because we can always summarize them with a single double inequality. All right, so these are the basics for writing our number lines, for doing interval notation and doing set builder notation. And then also for equations, just listing things out in combination. Now, what we'll do in another video is we'll talk about how to simplify combinations of inequalities when we have like and or conditions that we have to deal with for complex things. Particularly the or conditions are the ones that are going to show up when we deal with like piecewise functions or rational inequalities rational functions where we have a break in the domain.